Welcome to the presentation of the limit definition of a derivative. So I'm going to talk about how this equation or formula here is created. So to start off, let me draw a y-axis and let me draw another axis for the x-axis. And say we have a curved line here, something like that. Okay. And then we have 2 points on the curve. Let's say we have 2 points on the curve. We have this point P here and this point, let's say Q here. The x value here, because we don't know the exact x value, let's say this is just x, any x value on the x-axis, and the y value corresponding to that when you have a domain x is just the function itself, the f of x. For this one here, let me label it here. The label in this part here is actually x plus delta x. How this has happened, this is actually the scenario. This one here is a distance from here to here, or you can call it as change of x. And how did I know that this is x plus delta x? Let's have an actual example. Let's say we have a number line here, 2, 3, 4, and 5. From 2, how far is it going to 5? You know it's 3. You can count 1, 2, 3. So there are 3 units. And you can also do 5 minus 2. So there are 2 units. Rather, there are 3 units, 5 minus 2. To know here or to get here, you need to do 2 plus 3, which is actually 5. And that's the value there. And how did I get to? That's the value of reference here, which is this one. And this one here is a distance from here to here. So that's why 2 plus 3 is equal to 5. That's the same scenario here. So to get here is just the sum of this value and its distance from here to here. Okay? Now the actual or the corresponding function value of that somewhere here is actually f of x plus delta x. Let me erase the example that I have here. There you go. Okay, are we still following? I hope so. So assuming that I'm gonna do a line connecting 2 points, P and Q. So let me make sure I could connect. There you go. We call it as we call this as a secant line. Secant line is a line that intersects a curve into 2 points. Okay? So at least it can add in your vocabulary what secant line is. Now, what I'm going to do, guys, is assuming this point Q here is a fixed point, fixed, and point P is a non-fixed point, non-fixed. When you say non-fixed point, you would have an idea that the point is movable. However, it can only be moved along the curve, okay? So let's say, for example, I'm going to move point P closer and closer and closer to point Q. However, I will not allow it to be on top of point Q because if it were on top of point Q, you wouldn't have a line anymore. You would have a point. Remember, you need to have at least 2 points to make a line. Okay? So remember those concepts. So I'm gonna move this one here. Move, 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 and move. Until such time it gets closer and closer and closer here. So somewhere there. So let me draw the lines for you guys. So here, another line. Please bear with the lines that I drawn. As long as it should connect the 2 points. So there, there, and there. At some point, ladies and gentlemen, if we were going to magnify here, if we're going to magnify this, it would look like this. There. And one line that would somehow seemingly intersect at one point. So this is what we call tangent line. Tangent line, guys, is a line that intersects a curve into one point. So the more your P gets closer and closer and closer to Q, the line itself approaches to a tangent line. So from secant line to a tangent line. Okay? All right. So here, I'm going to draw another shape here. So from here, oh, let me change the color so that you would see it. Um, how about this one? I think this is better. This one here and this one here. Okay. Remember your slope of a straight line? Your slope of a straight line is actually rise over run. So here, the slope of a straight line is rise over run, meaning to say this is the distance of the vertical line and this is the distance of the horizontal line. Okay, the y value of this point here is actually y equals f of x plus delta x. And the y value of this point here is actually what? F of x. Okay. Now, how to know the distance from here to here, from this point to this point here? You can solve it by getting the distance from this very line going up there minus the distance here, minus this one, right? And you would get this green line here. So how to do that? That's going to be f of x plus delta x because from here going there, it's actually the y value. So if you notice, this is like a rectangular form. Whatever distance that you see here should be the same distance from here. So from here to there, it's actually f of x plus delta x minus the distance here, okay? Which is technically the length of from here to here, which is just f of x. Okay. Further on, it's actually the same manner. What I'm going to do is how to solve for the distance from here. Let me change the color to a green one. From here to here, because that's the corresponding run of the curve. What we can do is actually get the distance from there from this very line to here minus the distance here. So distance here, that's gonna be basically you would get the same distance here, right? So how to do that? That's just gonna be from this point to this point here, it's actually x plus delta x. And then the distance from here to here is just x. So simplifying the form we have, let me erase the tangent word here so that you can see the solution. Tangent and secant are just actually what? Additional information. So yeah. So I'm going to write here m equals f of x plus delta x minus f of x over delta x because you would know this would cancel out. X minus x is actually 0. Now, how come we have a limit here? Going back to our concepts earlier where P or point P is moving along the curve and gets closer and closer and closer to point Q. Imagine the mechanism. Whenever your point P moves going down here to point Q, the distance here from here would also move, it will also change from here going down to there, going down to X. And what happens with the distance actually is moving towards where? It's moving towards distance of 0. That's why we have the idea of limit as a delta x approaching to 0 and the rise over run concept minus f of x over delta x. That's how they come up with this limit definition of the derivative.